You just got to get those numbers and then put it in your calculator and get the integral. Okay. Consider the region in quadrant 1 bounded by the functions y equals x cubed and y equals 4x. Find a value of k, so the line x equals k divides the region in two regions of equal area. You know, when it says x equals k, that's really telling you that you're going to have the rectangles go up and down there. Not that we'd really want to choose anything else here. So it's quadrant 1. So this one's being specific, unlike this one. This one was not specific. Right? It didn't tell us it had to be quadrant 1. So it really should have said this, right? But this one's telling us we've got to be in quadrant 1. So there's my first. There's my second. We have some intersection points, okay? Okay. And we want to put this line here, x equals k, so that it divides it, okay? So as we set up our integrals, so the pink is the larger one for both, so 4x minus x cubed dx, and that's going to be from 0 to k. Okay. And this one's going to be from k to whatever that intersection is, and that intersection is going to be two. I'll finish it out, but I can see it's going to be 2. Okay. Okay. You can't really do this with a calculator. It says it's a calculator active, but you're going to actually have to calculate this. This is not say write an expression. It says, right, it says find a value, so we have to integrate this. So this is going to be 2x squared minus x to the 4th over 4 for k to 0. And this is going to be the same thing, 2x squared minus x to the 4th over 4 from 2 to k. Okay, I'm going to evaluate each of these. Okay, and if I put that in, I'll get 2k squared minus k to the 4th over 4. Lower bound goes away, great, equals, right, 8 minus 4 minus the lower bound of 2k squared minus k to the 4th over 4. Okay. So if I distribute the negative and move that over, I get 4k squared minus k to the 4th over 2 over 2, because you add a quarter and a quarter gives you 1/2, and then this is equal to 4, so I'll move this over here, right? Minus 4 equals 0. Okay. Now, since it's a calculator active, now is the time to use that calculator, and you would plug it into your calculator and find their solution. So whichever method you use, I told you guys I prefer using the grapher myself. We could probably solve this if we were in Algebra 2, but we did that before. We don't need to do it anymore. Okay, just be careful as you enter it. I know you guys have a better calculator than me, so yours is going to work a little bit better in terms of doing this. Looks like my intersection might even be 1, but let's just find that. Boom. Okay, what do we got? K is, oh, it's really close. K is about equal to 1.082. Okay. Now, yes, there's other intersections as we look at it. There's 1, 2, 3, 4. There's 4 different values of k. We wanted to make sure we were on the one that's between 0 and 2. This is the only answer that's between 0 and 2, so that must be our answer for this one. Okay. Okay. Last problem. Consider the same region from problem number 11. Now find a value of m, so the line y equals m divides the region into equal. Okay, so same thing, right? Same graph. Oh, these are great problems. I love these. Nice job on these. Actually, I think I got this from Miss Gray. Nice job, Miss Gray, on these. Shout out to Miss Gray for her great work on these. Okay, so there's going to be our line y equals 8. Okay, because we have that, we're going to have our rectangles go left to right. All right, so in that case, all right, we know where our intersections. We found it last time that this is 0, 0. Yes, we know that this is 2. We can figure out our y value just by plugging it in. All right, 8. Okay, 2, 8. Okay, so we're going to go from 0 to m, with the upper bound being x cubed minus 4x. Oh, wait, oops. oops, we need it in terms of y, that's right, because this is the thickness of y, so okay, let's fix that. So this is, the black one is going to be the cube root of y and minus y over 4. Okay, and then we're going to have m to 8, and it's going to be same function on top. Okay. Alright, this is still the larger one. If we remember, we got larger minus the smaller. This whole length is the change in x, so we have to go with the larger minus the smaller there. Okay. Again, this has to be in terms of y because that's in y there. Okay. So integrate. Nice thing is these are the same exact equations, so we don't have to worry about anything. It's just that when we plug it in, it's going to be a little different here. Okay. All right, let me go here to finish 12. 12 continued because I've run out of space. Okay. Start this up. Okay. Oops. Now we can see our work. Okay, so we'll plug it in. We have 3/4 m to the 4/3 minus m squared over 8. Lower bound goes away, great, equals 3 over 4. Oh, when we plug that in, it's going to be 16, great, minus 8, right? 8 squared divided by 8, so that's 8. Lower bound being 3/4 m to the 4/3 minus m squared over 8. Okay, distribute that negative in, move everything over. Right, I'm going to move it over here, so it's going to become 3/2 m to the 4/3 minus m squared over 4. Again, 1/8. This is a negative 1/8 minus 1/8, so it's negative 1/4. And then this right here is 12 minus 8, so this whole thing's 4, so minus 4 equals 0. Okay, graphing calculator time, right? X to the 4/3 minus x squared divided by 4 minus 4. Okay. Okay. Remembering, if there's more than one answer, we only care about the one between 0 and 8. Oh, it looks like we have a nice answer there. Looks like 0. Looks like 3 might be an answer for this. Okay. Oh, it's really close. So m is about equal to 2.828. Okay. So that's the value of m that will make those two regions equal. Okay, as I said before, that's a problem that's been on multiple AP in the past. Okay, hope that helps. Feel free to email me if you have any questions. Even if it's next week and Mr. Warner's taking over, you have questions about any of my work here, all right, just email me, and I can try to explain it for you. Okay, thanks a lot. Have a great weekend.